Very good morning to all of you. Today I want to start session 7 of module 4. Title of module 4 is bearing capacity of foundation, bearing capacity of shallow foundations. Course outcome is given, that is ability to determine bearing capacity of soil and achieve proficiency in proportioning shallow isolated and combined footings for uniform bearing pressures. Subject title is Applied Geotechnical Engineering. Subject code is 18 CV62 in 6th semester of Civil Engineering departments. Let us say, so in this session also some different numerical problems are required to solve. So last sessions also we have solved some different problems, and in this session also I want to solve some different cases of the problems to determine bearing capacity as well as size and shape of the footings. Let us say today problem, a square footing 2.5 meter into 2.5 meter is built on a homogeneous bed of sand of density 19 kilonewton per meter cube and having an angle of shearing resistance of 36 degree. The depth of foundation is 1.5 meter below the ground surface. Calculate the safe load that can be applied on the footing with a factor of safety of 3. Take bearing capacity factor as NC equal to 27, N gamma is given 30 and NQ is 30 and N gamma is given 35. Solution. Given data, size of the footing is given 2.5 meter by 2.5 meter, gamma is given 19 kilonewton per cubic meter, phi is given 36 degree, depth of footing is given 1.5 meter, factor of safety is given 3, bearing capacity factor that is NC equal to 27 is given, NQ equal to 30 is given and N gamma equal to 35. So these are the given data. To find SBC equal to how much? Procedure. Now draw the diagrams of the footing. So this is ground levels and depth of the footing DF is 1.5 meter and width of the footing is 2.5 meter and unit weight of soil is given, that is gamma is 19 kilonewton per meter cube. Okay, this is the diagram. Now follow the same procedures for calculation of SBC. First step, ultimate bearing capacity for square footing for general shear failure without water table is given by the following equations. QE equal to 1.3 times CNC plus gamma DF NQ plus 0.4 times B gamma N gamma. Now substitute the value in this equation. Okay, here 1.3 times C is 0, NC is 27 plus gamma is 19, DF is 1.5, NQ is 30 plus 0.4 times gamma is 19, B is 2.5 meter, N gamma is 35. So answer is we are getting 1520 kilonewton per meter square. This is the ultimate bearing capacity. Now solve the next step. Net ultimate bearing capacity is given by the relation QNU equal to QU minus gamma DF. So now substitute the value in this equation. QNU is 1520 minus gamma is 19 into DF is 1.5. Answer is 1491.5 kilonewton per meter square. Net safe bearing capacity is given by the equation QNU by factor of safety. Now substitute the value. Net ultimate bearing capacity is 1491.5 divided by factor of safety is 3. So now answer is 497.166 kilonewton per meter square. This is the net safe bearing capacity. Next, safe bearing capacity is given by the equation QS equal to net set bearing capacity, that is QNS plus overburden pressure gamma into dF. So here QNS is 497.166 plus gamma is 19 to dF is 1.5. Answer is 525.67 kilonewton per meter square. So this is the safe bearing capacity of the footings. So then safe load is calculated, Q equal to SBC into area of the footings. So load equal to area SBC into area of the footing. So now SBC is 525.67 into area of the footing is B into L, 2.5 into 2.5. So answer load is 3285.41 kilonewtons. So this is the safe load of this type of problem is calculated. Next problems, let us see what will be the gross and net set bearing pressure of sand having phi equal to 36 degree and effective weight 19 kilonewton per meter square under first case is 1.2 meter wide strip footing, second case is 1.2 meter side square footing, third condition is 1.2 meter diameter circular footings. Assume the footings are placed at 1.2 meter below the ground surface and that the water table is at a great depth. Also assume a factor of safety 3.0. Use Tursky's theory given for phi equal to 36 degree, NQ equal to 47 and N gamma equal to 43. Okay. Solutions, given problems, what are the given data in these problems? Okay, let us see. Phi is 36 degrees given, gamma is 19 kilonewton per cubic meter, dF is given 1.2 meter, water table at great depth, factor of safety is given 3.0, NQ is given 47, N gamma is given 43. Next, to find ultimate bearing capacity, QE equal to how much and SBC QS equal to how much for 1.2 meter wide strip, 1.2 meter square and 1.2 meter diameter circular footings. Procedures. In first case, if water table at great depth for strip footing, first case, so this is the footing dimensions, width is 1.2 meter, depth of the footing is 1.2 meter, saturated unit weight is given 19 kilonewton per cubic meter, depth of water table is great depth, means below the footings. So from here to here we are considering DW, means it is great depth, and this depth we are considering ZW2 is equal to B is equal to 1.2 meters, and this is ZW1s, that is equal to 1.2 meters. Ultimate bearing capacity is given by the equation. Now see, ultimate bearing capacity for strip footing is given by the following equations. QU equal to 1.3 times CNC plus gamma DF NQ into RW1 plus 0.5 times B gamma N gamma RW2. This is for general shear failure because sand is soil and phi is greater than 28 degree. Now calculate water reduction factors. RW1 equal to 0.5 times 1 plus ZW1 by D. In this equation you substitute the value. ZW1 is here 1.2 meter, D is 1.2 meter. So then RW is 1. Calculate RW2 equal to 0.5 times 1 plus ZW2 by B. So in this equation you substitute value. ZW2 is 1.2 meters, B is 1.2. So answer we are getting 1. So then substitute the value in the above equations, that is C is 0, then NQ is 0, NC is 0 plus gamma 19, depth of the footing is 1.2, NQ is 47, RW1 is 1 plus 0.5 times gamma is 19, B is 1.2 meter, N gamma is 43, RW2 is 1. So answer is 1561.8 kilonewton per meter square. Next, step number 2, net ultimate bearing capacity is given by the following equations, that is net ultimate bearing capacity equal to ultimate bearing capacity minus overburden pressure, that is gamma into dF. Now substitute the value in the equations, so we are getting 1539 kilonewton per meter square. So then now you calculate net safe bearing capacity is given by the equation net ultimate bearing capacity divided by factor of safety. Now substitute the value. Net ultimate bearing capacity is 1539 divided by factor of safety is 3. So answer is 513 kilonewton per meter square. The next step, calculate safe bearing capacity is given by the relation net safe bearing capacity plus gamma into dF. Substitute the value. QNS is 513 plus gamma is 19 into dF is 1.2. Answer is 535.80 kilonewton per meter square. So this is for this case. Next, for second case, for square footings. For square footing, diagram is same, but every time you draw the diagrams, don't forget the diagram. So this is the footing dimensions. Depth is 1.2 meter, breadth is 1.2 meter, ZW1 is 1.2 meter, depth of the water table, and this is at a great depth dW. This distance we are locating B is equal to B, that is ZW2 distance. Water table is at a great depth. So then now you calculate ultimate bearing capacity for square footing is given by the following equations, that is 1.3 times CNC plus gamma dF NQ into RW1 plus 0.4 times B gamma N gamma into RW2. In this case, here slight change for strip, here is 0.5, for square here is 0.4. So remaining steps are same. So now we calculate RW1 and RW2. Here RW1 is, while substituting in these equations, that is 0.5 times 1 plus ZW1 by T. So here 0.5 into 1 plus ZW1 is 1.2 meter from this. See, this is ZW1 1.2 and D is 1.2. See, this is D is 1.2. So we are getting answer is 1. Similarly, you calculate RW2. That equation is 0.5 times 1 plus ZW2 by B. Here 0.5 times 1 plus ZW2 is 1.2. Here see ZW2 is 1.2. So ZW2 is 1.2 divided by B is 1.2. So here this is B is 1.2 meter. So we are getting RW2 is 1. Then substitute the value in the above equations. So here sandy soil, this first parameter is 0 plus gamma is 19, dF is 1.2, NQ is 47, RW1 is 1 plus 0.4 times B is 1.2, gamma is 19, N gamma is 43, RW2 is 1. So answer is 1463.76 kilonewton per meter square. This is the ultimate bearing capacity in kilonewton per meter square. So the next step, net ultimate bearing capacity is given by the following equations, that is net ultimate bearing capacity QNU equal to QU minus gamma into dF. Here substitute the value in this concept. QU is 144, that is one, confirm this answer, okay. QU minus gamma is 19 into dF is 1.2. Answer is 1440.96 kilonewton per meter square, okay. So this value should be substitute here, okay. A slight mistake, no problems, okay. Next, net safe bearing capacity is given by the equations net ultimate bearing capacity divided by factor of safety. Here net ultimate bearing capacity is 1440.96 divided by factor of safety is 3. So answer is 480.32 kilonewton per meter square. This is net safe bearing capacity. Then calculate safe bearing capacity. QS is given by the equation QS equal to QNS plus overburden pressure gamma into dF. So here QNS is 480.32 plus gamma is 19 into df is depth of the footing is 1.2. So answer is 503.12 kilonewton per meter square. This is the solution for square footings. Third case, for circular footings. So now here draw the same diagram, but slight here is change. Here we are considering B is nothing but a D, that is the difference, and equation is slight change. Okay, but diagram is same. So once again you draw the diagram. This is the foundation diagram of depth 1.2 meter, width 1.2 meter, and saturated unit weight is 19 kilonewton per cubic meter, and from here to here, above the base of the footing, below the ground level, we are locating ZW1 is nothing but 1.2 meter, and this ZW2 we are locating equal to B, so is nothing but a 1.2, and from ground level to this water table, this is we are considering as a D depth of water table at a great depth, that is DW. So this is the diagrams. Now procedures, how to calculate SBC for circular footing. So step 1, ultimate bearing capacity for circular footing is given by the following equations. Q equal to 1.3 times CNC plus gamma df NQ into RW1 plus 0.3 times B gamma N gamma into RW2. Here we are considering B is equal to D for diameters. Okay. Next, now calculate water reduction factors. RW1 equal to 0.5 times 1 plus ZW1 by D. So now substitute the value in this equation. So here we are considering, okay, see in step 1 we have seen the equations. QU equal to 1.3 times CNC plus gamma df NQ RW1 plus 0.3 times B gamma N gamma into RW2. So this is here 0.3 is change, is a slight change for circular footing. Earlier for square footing 0.4 B gamma, but for stiff footing 0.5. Where here, see here only change numerical value, 0.5 for stiff footing, 0.4 for square footing, and here 0.3 for circular footings, and you consider B is equal to D. Now calculate once again water reduction factor. RW1 is given by the equations 0.5 times 1 plus ZW1 by D. In this equation you substitute the value 0.5 into 1 plus ZW1 here. So this is ZW1, this is 1.2 meters divided by D, depth of the footing. Here this is 1.2. So this is 1.2. So while solving these equations we are getting answer is 1. Similarly RW2 is given by the equation 0.5 times 1 plus ZW2 by B. So now substitute the value in this equation. 0.5 into 1 plus ZW2, see here ZW2 is equal to B is equal to 1.2 meter. So now substitute here 1.2 meter divided by B. B is here, this is 1.2 meter. So 1.2. So while solving this equation we are getting 1. Now substitute values in these equations. CSE is 0. So NC is 0 plus gamma is 19, DF is 1.2, NQ is 47, RW1 is 1 plus 0.3 into gamma is 19 into B is 1.2 into N gamma is 43 into RW2 is 1. So while solving this equation we are getting 1316.7 kilonewton per meter square. This is the solution of ultimate bearing capacity. Next step, you calculate net ultimate bearing capacity is given by the following equations. So that is QNU equal to QU minus gamma into DF. So here substitute the value. QU is 1316.7. See here 1316.7 minus gamma is 19. So this gamma is 19. okay, into df is 1.2. So depth of the footing, see, depth of the footing is 1.2. So this is 1.2. So while solving this equation, we are getting 1293.9 kilonewton per meter square. This is the net ultimate bearing capacity. Next step, you calculate net shape bearing capacity, that is QNS, is given by the relation QNS is given by QNU by factor of safety, that is net ultimate bearing capacity divided by factor of safety. Now substitute the value in this equation. QNU is 1293.9 divided by factor of safety is 3. See here, this factor of safety is here. See, factor of safety is 3. So this is factor of safety is 3. Okay. So here factor of safety is given 3. So while solving this, we are getting 431.3 kilonewton per meter square. And all of you remember unit also. Okay, don't forget units. So the next step, safe bearing capacity, that is QS, is given by the equations QS equal to QNS plus gamma into dF. That is QNS means net safe bearing capacity plus overburden pressure, that is unit weight of soil into depth of the footing. Now substitute the value in these equations. Okay, so here QNS is 431.3 plus gamma is 19 into dF is 1.2. So while solving these equations, we are getting 454.10 kilonewton per meter square. So this is the SBC for circular footings. So now you see how SBC is changed. For circular footing is 454, for square footing is 503, for strip footing is 535. Okay, strip footing is 535, square is 503, circular is 445. Means if the shape of the footing is changed, SBC is also changed. So that is the main conclusions of solving these three type of problems based on the water tables. Okay, next, these are the references or referrals. So one is Alam Singh and BC Punmya, second one is A.V. Narasimha Rao, third one is BC Punmya, next is Bowells, next is Bharat Singh and Shamsher Prakash, next one is Bureau of Indian Standard Code is referred, next this D.F. McCarthy, next D.W. Taylors, next Devil C. Moitra, G.N. Smith, Donald B. Kuto, H.P. Oja, by K. Tasky and R.B. Peck, K.R. Arora, MacDonald Bolton, P.C. Varghese, P.L. Kapper, Shamsher Prakash, Gopal Ranjan and Swami Saran. So like each author's, each textbook is referred. Okay, thank you one and all. Next class I will be continue. Okay.